Good morning, my dear students. Today I'm going to tell you about the definitions related to governance. Okay, so that is about first definition is what do you mean by controlling force, stability, sensitiveness, isochronism, effort, and power of a governor. Okay, so this is a very important question for the point of examination. They may ask you three different way of questions. Explain the following terms related to governors, or explain the characteristics of a governor, or with respect to governor, what do you what do you mean understand by the following terms. Okay, these are the questions they may ask you in the examination, but answers are same, don't make confused. Okay, so now let me understand what you mean by a controlling force. Okay, controlling force is nothing but with respect to governor I'm going to talking, that is how I'm going to speak. When a governor running each ball of a governor subject to an inward pull. Okay, consider a governor running at a steady speed, then the inward forcing acting on the rotating governor ball is known as controlling force. Okay, controlling force is nothing but if you take a motor governor, so when if you start the if you when if engine speed if engine shaft is started, then there is a either side of the ball going to rotate inward or outward. Okay, inward pull, outward push. Okay, so at the same time there would be chances of producing a centrifugal force, that is called as a controlling force. Okay, controlling force of a governor is equal and opposite to the centrifugal reaction. How much controlling force will be generated, that much of centrifugal force will be automatically generated, that is equal and opposite. Okay, so controlling force definition, that is a formula we are going to use in solving the problem. That is controlling force is equal to fc is equal to m omega square r. M is nothing but mass of the ball, omega is equal to angular speed, and r is the radius of rotation of the ball. Okay, so in Porter governor, controlling force is provided by the weight of the sleeve and the ball. Okay, in spring control governor, that is a hardener governor, controlling force is provided by the spring and weight. Okay, these are the two difference between the controlling force in the governor. Okay, that is Porter governor and Hartnell governor. Okay, so this is about the controlling force. Just to remember that controlling force is nothing but when a governor running each ball of a governor subject to a inward pull or outward push. When the engine speed is if you start the engine speed, there will be a rotation of the ball will be generated. During that, a force will be generated. That force is called as a controlling force, which formula is given by m omega square r. Okay, so next, second definition is stability of a governor. How we are going to call a stable in of a governor. Okay, a governor is said to be a stable when for every speed within the working range there is a definite configuration, that is there is a only one radius of the rotation of the governor ball at which the governor is in equilibrium position. Okay, so both the mass of the ball should be in equilibrium, and we cannot move the sleeve up and down movement. Okay, such condition we are going to call as a stable governor. Okay, so stability is nothing but a governor is said to be stable when for every speed within the working range the flywheel occupy the defined specified position. Okay, so it will have only the one radius of the rotation which the governor is in equilibrium. Okay, during stable condition the sleeve cannot be moved up and down direction, just to keep it in mind this. Okay, so this is about the stability of a governor. Okay, and next one is sensitiveness. So sensitiveness is nothing but it is defined as a ratio of an maximum to the minimum speed to the mean speed is called as a sensitivity. Okay, sensitivity. Okay, a governor is said to be sensitive if the radially respond to any change in the speed. Okay, so we are going to differentiate between the change of speed, that is maximum to minimum to the mean speed, that is called as sensitiveness. Okay, it may be defined as the ratio of the difference between the maximum and the minimum equilibrium speed to the mean speed. Okay, normally sensitiveness is denoted by lambda, that is the difference between the maximum speed to minimum speed. That is formula is given by lambda is equal to n2 minus n1 divided by n. Okay, so again the mean speed is nothing but n2 minus n1, again maximum plus minimum divided by 2, that is the mean speed of an engine. So by using this we are going to calculate the sensitivity of a governor. Okay, while solving the problem this formula we are going to use. Okay, next, isochronism governor. Okay, this question is very important. Two more questions they may ask you in the examination. So define isochronism of a governor, and they may ask you on direction or problem. Okay, so isochronism governor is nothing but when the equilibrium speed of a governor for all the radius of rotation of the ball within the working range by neglecting the friction then the governor is called as a isochronism governor. Okay, so I'm going to repeat here. When the equilibrium speed of a governor for all the radius of the rotation of the ball within the working range by neglecting the friction, then the governor is called as a isochronous governor. Okay, so suppose if the Porter governor or Hutton governor if you take, so here the radius of rotation when the engine speed will increase as the radiation of rotation of the ball will takes place. Okay, so during that a small friction will be generated that we are going to neglect in this. So for such condition we are going to call as isochronous governor. Okay, next is a hunting. This is very important. Hunting is result of too sensitiveness of a governor. Okay, so it causes the continuously fluctuation in an engine speed above and below the mean speed of an engine. Okay, so this phenomenon is called as an hunting. Okay, so in hunting, if the engine speed, if a engine shaft, if you once it is started, there is a fluctuation of energy in that is fluctuation of an engine takes place. So due to this this mechanism is called as this hunting. Okay, the high sensitiveness of a governor result in a substantial change in fuel supply for a small change in engine speed. Okay, so this is about the hunting. So hunting is very important term in solving the problem. Okay, so normally is hunting is nothing but if the speed of an engine controlled by the governor, then fluctuation continuously above and below the mean speed of an engine, then such condition is going to call as hunting. Okay, it is normally it is caused by a too sensitive governor. Higher the sensitivity of a governor in the problem, hunting becomes the more accurate. Okay, so this is about the hunting effort of a governor. Okay, so effort of governor is nothing but it is defined as a mean force exerted at the sleeve of the governor for a given percentage of a change in speed spindle. Okay, that is a limit, that is the bottom speed, the forces which will be exerted at the sleeve level. So that effort you are going to call as a effort of governor. Okay, when the governor running at a constant speed, the force exerted on the sleeve is 0. This is very important, and while solving the problem I am going to consider direct 0. Okay, so this is about the effort of a governor. Okay, so effort of governor is nothing but it is the mean force exerted on the sleeve to raise or lower it for a given percentage of change in speed is called as a effort of governor. Okay, so now the last definition is the effort of that is a the effort of governor. Okay, so it is the mean force exerted at the sleeve for a given percentage change of a speed or lift the sleeve or raise the sleeve. Okay, the power of a governor is the work done at the sleeve for a given percentage of change in speed. Okay, so normally it is a product of mean effort to then the distance through which the sleeve moves. Okay, so this is about the effort of governor. Okay, so what is the effect of friction on the governor? So this question asked, so I have taken this. When the loaded sleeve moves up and down the spindle, the frictional force acts on its direction opposite to the motion of the sleeve. Okay, so if you, for that condition you are going to consider the positive sign used when the sleeve moves upward if the that is the governor speed is increases, and at the opposite direction, and the sign is used when the sleeve moves downward, that is the governor speed decreases. Okay, so which governor is more sensitive? If you, this is a normal definition, this is a normal term going to get the student mind. A centrifugal governor is more complex to design and produce than the pneumatic governor. So however, the centrifugal designed to more sensitive to the speed changes, and hence it is better suited to the engine that experience a large fluctuation loading. Okay, so if the engine speed is suited for almost all the vehicle, that is called as sensitiveness of a governor. Okay, so it is, so this is about governor. And in governor it is governors are, the application of governors are, first of all there is a no governor in bikes, but it is normally used in almost all the cars and the other vehicles. These are some of the examples we are going to use this governor. Okay, this is about the small introduction about the characteristics of governor. Okay, thank you.